Hello world and welcome to Decode or Not to Code. I'm Millie Eva and as always I'm very happy to be here today and I'm here with Stefan. How are you doing?
I'm doing great because it appears this time we have not been banned yet.
Oh my goodness. Oh, don't jinx it. Oh my goodness. Fabulous. So yeah, I'm very happy that all of our viewers can be with us today. And yeah, let's see how far we get, I guess. Yeah, we're kind of continuing. If you've been here the last couple of times, we're continuing on our benchmarking the compiler extensions, the project, that we started a couple of streams ago. But before we get into all of that, please don't forget to like and subscribe. This is a stream, and we always love to hear and to reach out and to be reached out to from our followers. So if you have any questions, for us, any suggestions for the content or anything like that, I would just want to say hi. That's where you'll find us. And also, it's really, really important you subscribe to some of our social medias because we do stream like semi-regularly. So you won't know when we're back unless you follow us. So please do that now. And right, I guess it's time for our trivia section, isn't it?
Indeed. And for today, we were thinking about doing something, talk about performance a lot. So let's do a benchmark. Let's do a benchmark for trivia.
Yes.
Something that I guess a lot of developers do on quite a daily basis, building and filling lists. So
yes.
let's create a little list benchmarks. Yes, please. And we will do a bit of a setup, a global setup, where we shall create a list, private list of int, and we create a new list. There we go. We could also use collection expressions.
Yes, let's do that.
And let's do a benchmark where we are adding to that list wait a minute. If this benchmark is run a lot, we just continuously add. We could grow. Maybe we need to create this new list as well in the benchmark. Let's include that as well. Maybe let's keep it local. No setup. So let's create a new list. And let's, in the for loop, add. We could also do different iterations. I think we can do something like params and then have a property and could call it iterations. And let's say we do 10 and 100 and 1,000. And then let's use these iterations and let's add 1 through 10, 100, and 1,000 to the list. And then at the end, perhaps we will return that list. And this shall be our benchmark. Oops, list of int. We will gonna make this a short one because stream and such.
Yep. And Eric, you're not too late. You gave literally perfect timing because we just started with the with the trivia section when you joined. So good timing.
So we do a short one. Also have a memory diagnoser, which then after the regular one, so like this add method is invoked a lot of times to get some statistics, and then at the end one additional one that only is used to determine memory statistics. So what are we allocating? And let's take a peek at that. Let's open the terminal. And let's go to here and run the run the benchmarks in release mode. List benchmarks. There we go.
Oh, it's really good. It looked like we choreographed it, but we just both went like this.
Oh, did we? Is that the equivalent of some gaming show waiting and thinking music?
Yeah. Yeah.
And yeah, what we're gonna see is how it works to add items to a list. We will see that. Is it completed? Yes. That quite a lot of memory is allocated. For the one with 10, takes 50 nanoseconds to add 10 items, but allocates 216 bytes. Now let's wait a second. So there is a bit of overhead with a list because that's an object, and internally it is an array, another object. But roughly, if we have 10 items, those 10 items are integers. So that's a int 33. So that's 33 bytes, 34 bits. So that's 4 bytes. Is it? Yes. So it should be, and then there is it like 32 bytes or something of overhead? So there should be like roughly something with 100 bytes, but not 200 bytes. That is significantly more.
Yeah.
Why is that? And also, for the other ones, it's even more. It's more severe. It seems to be the larger the list goes, the more we exponentially allocate, kind of a thing. Let's see what will happen if we would do the same thing in a bit of a profiling session to understand, okay, what's going on. Let's run this maybe a lot, 100, 1,000 times should be all right. Excluding the benchmark.net stuff, and let's profile this. I always forget what's better, or profiling with sampling or tracing.
I've never profiled anything, I don't think. Have I done this before?
Not really, no.
No. Okay.
I always click
sometimes I forget things, but at least, this seems really new.
I always click like sum and then see if it gives a result that yields some information. And what we see is that there is another method called that add method is that we call.
Yeah.
We also call a constructor, but that's like a significant portion of the time, and we can't optimize the constructor. But we also called a bunch of times so here's our 100 million calls. Excuse me. Can we? Well, let's find out.
New project. No.
But there's also add with resize. So there is some resizing going on because how list works under the hood. If we take a peek at the implementation of list, we will see it's an array.
Yep.
There is a size and a version. I think the version is used when you add to a list or remove from a list, then this version increases. And the iterator is checking the version. So if we go to the getEnumerator method, first the getEnumerable.
Yep.
GetEnumerator, and this enumerator, while move nexting, is checking the version. And if the version has changed, we will throw an exception so that you don't change the list while enumerating.
Like with an interceptor or something.
No. Well, not a C# interceptor.
Oh.
But it's just code that runs as part of the enumerator. So when moving the next item, that you can then get via the current property.
Yeah.
There is also a check of the version. So when you start enumeration, the current version of the list is snapshotted.
But how can you change then, though?
Well, if I basically multi-threading. So let's say I have one thread adding something, and I have another thread iterating through this list. And if this is done concurrently, I will get an exception. Then, hey, while enumerating through the list, please don't change that list.
Got it.
In single-threaded code, can't happen. When concurrency is going on, then it can. So list isn't thread safe. And that's one way to ensure it, because the internal state actually can change. Because an array, well, only has a specific size. And we also have here default capacity. So you can set the capacity and the initial capacity. So with the first add, we will create an array of length 4. And then adding the first item to it. So the array's length will be 4. And after the first add, size will be 1, which indicates, okay, this array has 1 item, but can fit 3 more. Then we do the next add, and the next add, and the next add, and now our size equals the length of the array, or the capacity. Now, if we do the 5th add, we can't add index 4 to an array with a length of 4. We need to grow. And the default algorithm that is currently in use is doubling the size. That means now a new array of size 8, actually. So a new array of size 8 is now allocated. So we still have the old array. It has 0, 1, 2, and 3 in it, but now it's full. So we allocate a new array with length 8. It's double. Copy all of the items over to the new array. Lose the reference to this original array so that this original array is now subject to garbage collection. And start adding now the new item into this 5th array. And again, we can now add 3 more items, 6, 7, 8, but with item number 9, again, we're out of size. So we need to grow again. And then we grow from 8 to 16. Again, copy the items over. Now I have 8 more, can do 8 more adds. And if 16 is full, then we go to 23 and 64 and so on and so forth. But if I know ahead of time that I'm gonna add a specific set of items, I can, as an optimization, I don't need to, maybe let's say I know I'm gonna add 100,000 items. We will create a lot of intermediate arrays that get full, create then a new array, copy the items over and move and lose the previous array. So we're gonna basically generate a lot of garbage. And this is why these most collections also have a constructor overload that takes the capacity. And if I would set the capacity to 100,000, that now means that we get immediately an array with that capacity created. So we can now fit all of the items without a single regrowth.
That's nice.
And if we run that, then we shouldn't see this add with resize method anymore. I didn't check the performance. Should also be a bit faster because we no longer create new arrays and copy items over. And well, can also do the benchmark again. And here now, well, if we do that in the benchmark, let's go to the list benchmark. Let's copy this one over and let's say add capacity. And let's also do a new list, and we set the capacity to the amount of iterations so that we do not have a regrow. We're actually creating the exact size that we're going to have. If we were to do one more iteration, this one additional operation addition would cause a regrowth again, because
and then it would double again.
Then it would double, yes.
That would actually be quite a lot of space.
Actually, in this case now, yes, because we no longer use the default capacity of 4, we now use the capacity of 10, but it's still the same doubling algorithm. So it's now doubling to 20. If 20 is full, we go 40. If 40 is full, we go 80.
Yeah, okay, but when you had like 100,000 or like 1 million.
Yeah, I guess.
That would be...
What's again the max? There is, I think, if we do array.max length, there is a max length that an array can have, which, damn it, I can't read hexadecimal. Maybe let's ask.
What? You can't.
Yeah. No, I can't. Let's go to.
I can't either.
Well, I guess let's just run .NET code. Array.max length. Let's run that. If it compiles still, well, while it does, maybe switch over to SharpLab.
Now we've got all of it back, yeah.
And
Sharplet hasn't been on the stream in a while.
That thinks, tooling is beating us today, is it? No, there we go. Okay, so 2 billion something. I think.
Okay, so we can double.
I have a déjà vu. This is the max of an int32, isn't it? Max value. Is it? Oh no, but quite.
But you were close.
Quite.
Yeah.
So with the 100 million, we could regrow once to 200 million.
Yeah.
But then trying to regrow to 400 million will crash, will cause an exception.
Okay.
And yeah, when we now take a peek, did the benchmark run? Did it not run? No. Let's see, release.
Oh, you have a typo.
Oh, because, yeah, foolish, Stefan. Didn't have the correct code in. List, yeah. I was hoping the benchmark was done well. Well, yeah, we'll now see a difference between the two. So the one where we set the capacity ahead of time because we know should be a little bit faster, but also allocate significantly less memory because we don't create intermediate arrays that grow and grow and double and double and double.
Yeah.
And let's wait. Maybe let's cancel that. Let's do only 100,000 to show the difference.
That's 1,000. Right?
1,000, yes. To show the difference between the two to be done quicker. I guess now I do the move again.
That was so good. We were also talking like for a while now about like having like just like a blooper reel of like funny things that we did on the stream. We have some really good, and I think this one would actually go in as well. I don't know, it's not as like big or like I don't know fancy as our other bloopers, but I just thought it was brilliant because we spend too much time together, I think. We've already got the same like waiting move when it comes to benchmarks. But that was quite an unexpected like side effect of like these benchmarking episodes that we had sort of promised for like years. And I think it was years, multiple years. I don't think it was a year. Yeah. Is that, I mean, obviously it's like a everybody loves benchmarks. And I think it's something that everyone's interested in, no matter, you know, what you like, what your special or like your favorite things are. Benchmarking is actually always somewhat interesting. But actually for a stream, it's really difficult because you always have to wait. And like, even if you do like the fast run, and we did have like problems with it then not being as accurate, blah, 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 and also having the stream run and doing benchmarks is actually not the easiest topic to do in this format. But we managed. Yeah.
Well, at least we may not get accurate numbers, but we get an estimation. And yeah, well, we do see it's a little bit faster. Well, I guess creating arrays and copying over data from arrays, because it's all contiguous memory. An array isn't separated in several slices. It's continuous in memory. So that creating new arrays and copying over from arrays, that's super fast. So yeah, the difference. Well, but we do see a bit of a performance difference. But yeah, significant part is in the allocations, and we no longer have these growth. So we have only one array, have its final size, and all is cool.
That's really cool. That's actually like quite a significant difference. So yeah, if you want
it could also be, let's say you know, like, hey, I'm gonna add up to 20 items,
Yep.
but not necessarily whatever
Yep.
this now is. But you know it's up to 20 items, and then maybe some user code or something happens, and maybe you then hold on to this list for a while, but without adding or changing it anymore. But what if you only added like 6 items? And if you're holding on to it for a while, we kind of now waste space of 14 items. So in this case, 14 by 32-bit or 4-byte. Well, it's not a lot. Does it matter? Probably not in this case. But in general, if you're done with adding and you now do a bit of optimization and have the array size exact because you're holding on it for a longer time, you could also do, I think there's something like trimming. Is it ensure capacity? No. Oh, I'm not sure if this list actually has that. Oh, there it is. Yes, it has. Trim excess, which is now creating a new array, but with the exact size that we currently have. So we still allocate a new array, but if we have in an array of 20 only 4 items in use, we would create a new array with size 4, and we'll be then using that. So if you're holding on to the array longer and you want to free up this excess memory because you created some buffer, and then you could optimize your memory a little bit. But I guess then you really need to do some profiling to find out, hey, is this extra allocation worth it just to freeing up a bit of memory? I guess, it depends on in detail, but that's just another feature of the list as well. As well as if I don't know the capacity already at initialization, but maybe later on I do some operations and then later on I know, hey, now I need a list that has at least a capacity of 100 because I'm gonna do more additions. You can also say ensure capacity. And if I now say ensure capacity 100, well, it will make sure that the capacity is at least 100. So if the capacity currently is, for some reasons, 101, this will not do anything. But if the capacity is less than 100, it will now create a new array that has this capacity and copy the things over. We cannot take a peek at the look. We see if the current length, so if the items in use is less than the capacity requested, we grow. And then create a new array.
Yeah.
But if you're fitting, if you're fitting the elements in that we currently have in that capacity, I said I need at least 8 items, but the array already has a length of 8 or more, we don't need to grow. And I think this is mostly then the performance and memory respective features of the list, if I haven't missed anything.
Awesome. Well, that's good to know, definitely. And now we can go back to more benchmarking.
Benchmarking. I'm not sure.
What's this?
Why site was found? I don't know. I clicked something. Cool. So last time we found out, well, they actually found out previous time, but we weren't sure. We thought we made a mistake, but apparently it was okay. Well, we now learned which methods to call. I think this is in the other type of iterations. So we don't want to call and update compilation. Well, we want to do one generous and update compilation. Also, maybe context, So building a benchmarking tool that facilitates benchmarking Roslyn source generators.
Yes.
And on the foundation, we have this generator driver that we're gonna wrap and offer an API that makes you fall in the pit of success, what to say. And we facilitate some tedious setup. And with more iterations of the tool, we can always add more easier ways of setting it all up. Maybe we could also do something file-based that we read, hey, this document, read it in as a text and pass it and compile it. But future stuff. And then we found out that for running the generator, we want to run generators and not run generators and update compilation.
Yep.
But we do want to run one generation adaptive compilation if then at the end we also want to do a bit of a verification. We don't want to provide a full testing framework, but some verification, because we actually had a mistake where if we weren't throwing some exception indicating, hey, you're not generating what you think you're generating, or the generator isn't doing what you think you're generating, then the benchmark, the outcome is basically pointless because it's not measuring what I think it's measuring, and then I make wrong assumptions.
Fair enough.
And I guess this leads now to the scenarios of where our library could be useful. It's, well, for the use with benchmark.net, where we have like a global setup kind of a thing, the benchmark method, which iteratively runs the generator, not iteratively, but continuously, and potentially for the global cleanup, then do some verification. And in the setup, we do some initialization. And here we do invoke or run or whatever we call that method. Another scenario would be profiling. Just what we saw earlier, that we maybe we still have this kind of a same setup and still have the same method, but another use case could be that it's not used with benchmark.net, but the user just has some for loop and runs the invoke/run a couple of times, and then does some profiling, because the profiling tools then can maybe show the hot paths, so which aspects are called a lot, where is a bit of room for optimizations. Can I get rid of some maybe array growths, because a lot of array growths, maybe I have a list and the list grows a lot, so maybe I can use a capacity to avoid that. And so benchmark.net kind of is good for comparing different versions of your code and see if it gets faster and or allocates less memory. And profiling then is good to find out where you actually may have improvements. And I suppose then could also have something like memory snapshots, as Rider supports. We can do just a breakpoint, do a memory snapshot, run some method, do another snapshot, and then see the diff. So this would be kind of the scenarios that we would like to provide. We get a tip. If we haven't tried it, it's been a while since I used LinkPad last. Benchmark. They are obviously not similar, but they are great. I'm actually, do they have something?
Let's have a look.
LinkPad. And I haven't been there in a while, to be fair. Incorporate with benchmark. I didn't know. They also have benchmark.net inclusion, so you can just. This could also be yet another use case to be used out of LinkPad. So it seems I just mark two methods, do Control-Shift-B, and then it automatically, for me, if I get that right, then runs benchmark.net. So I save a lot of overhead of writing the benchmark attributes and such. I just write a 3 lines of code, have two local function here. I think those are local. No, actually, not sure. I think those are local functions or just top level. Never mind. I think they were local functions, yeah. And then can just Control-Shift-B it. That's pretty cool.
That's pretty cool. I really like the name .NET Swiss Army Knife. That reminds me of and another name for another project that you came up with.
Don't want to spoil it.
Yours is better, but we're not going to spoil it.
Not yet.
Hi, Stuart. Thanks so much for joining.
So for auto-completion...
No, what?
Feature, yeah.
Oh my God, that's actually, if they ever that's actually a really good way to make money, because...
Well, that's reasonably priced.
If they get rid of autocomplete, I'm a different person altogether.
Yeah, well, I can't. I wouldn't know how to code anything for autocompletion. I just do see what's available.
I know. And me too. That was another thing that I had to relearn with talks that we did. Yeah. I wrote my first for each, I think, without auto-completion in years.
A friend of mine once said, yeah, he doesn't really code. He just writes a bunch of text and then in writer does Alt-Enter as many times until it compiles and runs good and fast. Alt-Enter, Alt-Enter,
Yeah.
Alt-Enter. I suppose these days you do prompt until it gets better. Or maybe a combination. I still think that although LMs are pretty powerful in generating code, I think that the deterministic fashion of Roslyn-based code completions and Roslyn-based fixes are still valuable. And perhaps we're going to build something that helps LLMs invoke that. But I'm teasing.
Okay. Well, awesome. We've got our...
Ooh, that's interesting. Hello, Jason. Joining. Visual Basic 3 didn't have IntelliSense. We all have it too easy. Yeah, yes, indeed. Oh, wow. That's actually... So I guess I compile it then, and then I see, yeah, this doesn't exist. This member not found. Okay, cool. That's not really... I guess there wasn't also some helpers. CLI tools these days are pretty good. Some CLI tools, if you do a typo, then they kind of offer, hey, did you mean this or that? And find like a closest match. I suppose this haven't been around in VB3 days.
Yeah.
Cool. Now, would you like to start with building this helper type?
Helper type?
Yeah.
So like...
The question is how... Yes, that's not a question. How do we call it?
Where's the prompt? No, I don't need it. I've got wonderfully, capable people in this stream. What did we have when we had like also an episode where you were Stefan GPT or something like that? That was really funny.
Excuse me, can I come in? I didn't catch it.
No, it's not. It was just, yeah. Never mind. What are we calling it?
So what's it?
Summer episodes. I'm always like rambling about. Okay.
I suppose we'll also be later. Then we'll be adding also helpers for diagnostic analyzers, also for code fix providers, and so on. What else do we have? Code fix providers, refactoring. Is this a refactoring provider? Not sure. Is it just refactoring? Well, not sure anymore. And also, well, do we also want to support source generators or just the incremental one /I incremental generator? But these really could be covered by the same type. And we may also, what's the last one? Diagnostic suppressor, perhaps. And there is also code completion providers. I think this is what we could, these types. So I guess if we now, but this would also be the 5 types that we kind of offer. So I suppose it would be good to somewhat include generators. Oops, that's iSource sources, iSource generator. So perhaps something with generator in the name, and something with benchmark, because kind of, well, it doesn't really do the benchmarking itself, it facilitates it. Something with benchmark, something with profile
helper.
Invoker, because it invokes. That sounds quite weird.
What?
No, I'm just putting in some names. Whatever you like. Well, we won't publish it immediately, so we can still change it.
So like benchmark helper is fine. Benchmark invoker.
Maybe.
Benchmark profiling help invoker helper. Invocation helper.
We should also include something with generator.
Benchmarking class. That was autocomplete.
Generator benchmark.
generator benchmark.
Yeah, and then we could have an analyzer benchmark and a code fix benchmark and a refactoring benchmark and a code completion benchmark.
Ah, I like that.
And a suppressor benchmark.
Yeah.
Although itself, maybe the name benchmark isn't that perfect because itself isn't a benchmark.
Yeah,
It's just a helper. So benchmark helper, but I don't like the name helper is weird.
Benchmarker is autocompletion.
Benchmarker. Is this a word? Let's go with it. We can always change that. I mean, we are in benchmarking, so we have a benchmarker. Cool.
Okay.
Yeah. Then I guess now what we do is create methods and move the code that we have, existing into this type, and then, basically bring this into shape. So to have these use cases, I guess we could have, so for the initialization portion, I guess we could have different ways. We could have a constructor. We could have a factory method. So that's a static factory method, usually called something with create. We could also, just do a default constructor and then have an initialize method. I suppose the differences are, do we want to reuse this? Do we want to set up an instance of this type only once so that it's then fixed and we can't change the setup portion, so we can't change the compilation, we can't add sources, for example? Or should it be kind of mutable to allow reinitializing or adding new files to the compilation or something like that? So I guess the first question you need to answer, do we want to design it immutable or mutable?
Immutable?
Well, we are in the Roslyn context, so immutable sounds reasonable. No, Roslyn, not reasonable. I'm not sure. I'm typing weird today. Okay, so we could
it's summer, yeah.
So I guess now it's up to preference. So we could either basically have the scenario where we write something with a constructor and then pass arguments to that constructor. Or it doesn't let me. It tries to fix my mistakes, but I want to make an
You want to make a mistake.
Conscious mistake, yes. Or we make the
just
constructor.
let me type.
Or we make the constructor private, and then we have a create method. I guess those are the two. What's really the difference? Yeah, I guess that's up to preference.
Create sounds cool.
Do you think?
What are the pros and cons again?
The pros and cons. Well, if we make the constructor private, then we can't do the upper portion because it will say constructor not found.
Yeah. And then we have a create method.
Usually the differences are if you want to create a type without exposing the type. Now, does this make sense? No. If we had a hierarchy, so if we had, let's say, public class A and public class B, or actually the class B is internal. That's something that we do not want to show because maybe we have different variants. We have A, an abstract class, so that cannot be created. And we have variants B and C, but those are internal implementation details of what we offer. And then we would, there's an abstract class. We don't even need to hide the constructor. We can construct it, but then you could have, B and C can't be constructed either because they're internal, so the consumer doesn't see them. But we then could have a public A return a static, the factory method, static A returning create method, where we pass in some arguments, and now basically do a Boolean just to showcase, and then say if this Boolean is true as an implementation detail, but the user doesn't know, return a B, Otherwise, return a C. But the user doesn't see that there is a C. Now, not sure if this makes sense, but as an implementation detail. And now if I do, if I now invoke a.create, oops, I need another method. Let's do public void, public class consumer. If I now say a.create, I only see, okay, it will be an instance of the base of the abstract class A, but I do not know here whether a instance of B or an instance of C was created. So if you want to keep inheritance kind of private, if you don't want to expose that inheritance, and basically can offer different implementation details. I think this is how string value is doing it. No, not string value. What's that? Search value. There's a type called search values, and we can create search values. Search values itself is that's a static class. It has there is a generic version of it. And this is, okay, it's a non-sealed type, but the constructor is not accessible. It's non-public. So we cannot create instances of search values. But .NET now, depending on what we pass to create, now uses different implementations, like an empty search values and any one search value. So they have different highly optimized implementations of this abstract class. And without exposing these types, so they can rename it and change anything about them, they can still be creatable. Long story short, if we have a hierarchy that we want to hide, then I guess a factory method is the go-to. If this is a singular class that's not really inherited, that isn't inherited further, so if we would make this sealed, then there isn't really a benefit of having a create method, and then a constructor would be the more straightforward way of creation.
Yeah. So do we need to hide anything if we're building it on a stream? No, I mean.
Well, what could be, I'm not sure if we need it, but what we could have is maybe as an implementation detail, we could have, if this type was not sealed, we could have a derived source generator benchmarker, and a derived incremental generator. So if there is some, and then we don't, and then we just say, and then we have two different create methods, one that takes an source generator and one that does incremental generator, and then we don't need to expose two different types. We just say create, pass whatever, and internally then we do the right thing. Not sure if we're gonna need it though. So maybe let's start with just a good old constructor. And if we see that we have kind of different implementations depending on the version, if it's an iSource generator or a non-iSource generator, then we can switch to the create method.
Okay.
So long story short, let's create a constructor.
Okay. And autocomplete.
Cool.
And
then
what does this need?
Well, let's figure it out. Let's create let's create a bit of the shape yet, and then we fill the pieces. So that's kind of the initialization portion. Then we need to have the method that is run potentially multiple times to get some benchmark statistics, to get some profiling data out of that. How would we like to call this method? I think that the generator runner calls it, run. I think benchmark.net calls one iteration of this benchmark method. I think that's called an invocation, so kind of an invoke. I guess it would be cool to choose a name that we would reuse for the others as well. I'm not sure if, for example, a diagnostic analyzer would also have the name of run. I'm now thinking of, I'm not thinking of either run or invoke.
Yeah. Run. Run is good. Public. Is it public? Is it private? Is it what is it?
No, this is now we define the public shape, and then the rest of the methods will make some private internal helpers.
No, where's my autocomplete? No, that's not what we want. And then just what do we return some result? Or do we need?
Let's make it wait for now.
Okay.
If we know what to return, then we can return it later.
Does this need to be static or something?
No, this would be an instance method.
Oh no! It autocomplete didn't like our naming. Right.
And then for the last portion, we need something, for the cleanup. So some verify, test, check, something that indicates that it throws if it doesn't meet the expectation that we pass in. So we'll be passing in maybe the generated sources that we expect to be generated, and then it throws an exception if it wasn't, maybe.
Like
something in the terms of
like a safety net.
Kind of a check, verify, ensure, something in that term.
Ensure? No.
Yeah, that sounds weird indeed.
Well, then I guess verify is good.
Let's do verify.
Maybe? Verify.
Cool. And now let's move the parts over that we need. So in the one should be only doing basically the one generator method. For that, we need the driver. So I suppose in the constructor, we need to create the driver, the generator driver. So we need a field because that's the shared aspect. We need the generator driver as a field.
As a public field?
No, let's hide this field. We don't want to, because those three methods are the only methods that are public, and perhaps we have more overrides to them or overloads to them. But the rest is now private or internal.
What is it? Generator driver?
Generator driver, I suppose Jason is suggesting to use AI tools to give some name suggestions.
Yes, please. Name suggestions.
And also, naming is hard.
It's the worst. But this should be does this have a getter and setter, or is this?
No. This is just a field.
Okay.
But let's not. Yeah, let's not.
No.
Let's just, and then let's ensure to set it in the constructor. I'll just do Alt Enter because I'm not sure if you got. Wait a second. Oh, we are not. We're missing the package. We missed the dependency. Yeah, that's just a basic library. What do we need? I think we need. Yeah, I believe we need only that. So let's install the package of Microsoft extension C#, which should provide the type that we need. But we have the generator drivers implementation detail, so let's not accept it as a parameter. We'll be passing in the pieces that are needed, but we'll hide it that this generator, this driver is in place.
Okay.
Do I need to build to get the suggestion of Microsoft extensions? There we go. Cool. So let's create the generator driver. So let's create a new driver and assign it in the constructor. And then we see what the generator driver needs, and then we in turn feed them in as dependencies.
Okay, but do you like new? No.
I'm not sure if this one does it have a constructor. Let's see if it works. Not sure if it has if a generator driver has a constructor or indeed has a. Well, actually, we did this last time, so let's find out. Oh no, generator driver does not have a constructor. This one has a create method.
Aha, perfect.
So we need to say C# generator driver dot create. Actually, no, the constructors are kept private and internal. So we need to. So in our constructor, we can say driver is the generator driver dot C# generator driver dot create.
Driver is C#. No. Yes.
And oops. So what do we need for that? Let's take a peek. In order to create a generator driver, well, we need a generator, a source generator. A source generator must have a parameterless accessible constructor.
Perfect.
So what we could do is we could generically accept a instance of I-incremental generator, but as a generic type parameter, and then create this instance ourselves with generic constraints. I'm not sure if you have done that yet, but let's come to that. So since we are now generic, we need to make the type generic. Maybe this is now an indicator that perhaps we do want to make this. Maybe we do want to do this hierarchy and hiding and have maybe a factory method, but we find that out. And yeah, that looks good. But now since you generated, you need to explain to me what you just did. Do you know what that does?
Yeah, so like T has to be in some I-incremental generator, and I don't know, the new, I guess, is if it's empty, then we create a new one. No.
This new, that's a generic constraint that says that the type that you pass in here, first of all, must be constructible. So it cannot be the interface itself. It must be a type. It must be a type that implements this interface.
Yeah.
As well as it must have a accessible constructor, an accessible parameterless constructor. So if we now jump to our busy generator, this currently has an implicit public constructor. If I were saying, well, constructor, now this is an explicit public constructor, still the same thing. If I now say, now this takes an integer, there is no parameterless public constructor anymore. So this type is violating the new constraint. If I either have explicitly a parameterless constructor or don't have any constructor at all and get just the default generated parameterless constructor, this type is now confirming to the new constraint. And since generators need to have, I think this is also what tooling expect. They need to have this parameterless constructor. Otherwise, the tooling doesn't know how to create them. Therefore, this constraint is valid. Yeah. Which now means that since this is a generic constraint, now the caller is constrained to only providing types that are constructible via the default parameterless constructor. If this type doesn't have it, then it doesn't work. But whenever there is a generic constraint, that means that the callee now is more powerful. So we can actually create instances of this T because the constraint is assuring that a parameterless constructor does exist. So we should now be able to say new T, which we couldn't before.
Okay. Should we do that? New T.
New T. And this works.
And then
if I were to remove this generic constraint, this won't work.
Oh.
But when we have this new constraint, this is now calling the parameterless accessible constructor of this type that we provide.
Nice.
Maybe we don't call this T, but generator.
Okay.
Because it will be an instance of an incremental generator. Now we should be able to pass this to the driver.
Okay. Or do we want to inline it and just have new T in?
However you prefer. I'm not checking what else we did, if there are some more overloads. Well, there is also an option, because the generator driver can have multiple generators. But I suppose we don't really need... When we benchmark, I suppose we only want to benchmark a single one. Can always extend to accept more, but yeah, let's only have the one. Cool. All right, so we have the driver. Let's not create a new local variable here, but let's assign it to the field that we have so that we can use it in the run method.
No.
And yeah, in the run method, let's call the one generators method.
Oops. Oops. Run generators. Yep.
Now, one generators requires there's different overloads, but it requires, well, it also supports cancellation, but we will not cancel. It also has a generator filter context. I do not know these. Now, of course, I need to go explore them. So there is a func, which a generator filter. I suppose this is how we could suppress specific generators if they... Oh, there's this host production context again that we saw last time. I'm obsessed by this. I don't know what it is, but we'll figure it out in the future.
Did you? Oh,
yeah,
this could have been also good trivia.
This is just in short. Well, we were gonna build later a tool that shows what it does and exposes what it does. But long story short, it's a new way of producing auxiliary information for tools to inspect.
Nice.
Which our tool then will be doing. But yeah, again, teasing. So I guess what we need is a compilation. And since we have the C# generator driver, we should be passing a C# compilation. So let's try to create the C# compilation in a step before. Well, I suppose actually we don't want to create the compilation with every one because we don't want to measure creating a compilation, but let's also do this in constructor. So while initializing.
Yep. Compilation.
Let's see. Can we do new C#?
New.
Actually, again, we did this already. No need to go through that hassle again. C#. No, that's also a factory method. C# compilation.create. Without the new, because it doesn't have... No, it doesn't have a constructor.
Yeah. Okay.
Or does it? Yes, does, but they're all private.
No. No. Sorry.
Oh, are there other? I don't know. Are there other overloads? Create script compilation. Yeah, we're not doing a script compilation. Cool. And this one now takes an assembly name, so you can pass just any assembly name. Whatever you like.
Like a hard-coded name?
Yeah.
Ooh. My compilation? No, that's boring.
Something in our benchmarking terms. Benchmarking compilation, C# compilation, something like that.
Okay.
Now, and we need syntax trees.
Yes.
So we need to create syntax trees. And I suppose, again, but we need syntax trees. Well... Yes, but no.
Yeah, okay.
Yes. So where do we get the syntax trees from? In last session, we also created these by, again, there is a C# syntax tree dot parse, or C# syntax tree. Again, these have factory methods. So let's do in the step before. So let's create an array of syntax trees. Is that an array actually? Oops, sorry. That is an enumerable. Yeah, but let's create an array of syntax trees. And we create a new syntax tree by saying syntax tree dot something.
And also just a syntax tree here as well, or what?
No. So this will be the array of syntax trees that we create. So let's say syntax tree array.
Yeah.
And we create now one syntax tree by saying syntax tree dot something. Because again, if the syntax tree doesn't have the constructors, but they say syntax tree dot, or is it C# syntax tree actually? I think it's C# syntax tree. Yeah. Syntax tree, C# syntax tree dot something.
Gotcha. Dot something. Great.
What is there? There is a create. What does this take? Oh, okay. This takes C# syntax nodes. So this is using the Roslyn, the syntax tree API. But I guess we want to be more string based. So I think there are also, let's use the parse text overload, the parse text method group.
No. Okay. No. So this is where I become a whole new person when the auto-completion doesn't work. Okay.
And in here, we now have various options of passing source text, strings, and yeah. And this will actually now be the input of the user. So the user needs to provide the string or a collection of strings that we could now decide. We could say, pass us syntax trees, or we could say, give us a string and we create a syntax tree out of it. I guess that's now a question of how we want to design our APIs.
Yeah. I don't know. What's the more common use case, or like the more common?
Well, for our case, I guess we kind of wanted to pass in a string. So if it's, I guess, to have the least work for the caller, it would be just accepting a string.
Okay. So we need a field with a string, right?
No. But we need to accept this in the constructor. So this needs to be passed in. I think, let's see how this is called, when the string to use the same name, text.
Wonderful.
But okay, we also have, when it comes to syntax trees, you can also have options, I guess, and encodings. Maybe this is something that we would, maybe we should accept just syntax trees and then leave it to the user to create them. Or we could also provide overloads. We could allow both. We could have an overload that just takes a text, and we do whatever we think we do. But we also have an overload that takes a syntax tree, and the user has more flexibility, more power over creating these. So we have a bit of a shorthand version and a more powerful version. So let's start with the text, and then let's also later on create a overload with syntax instead of text.
But I need to add this, no, right?
No, well, oops. We can't. We don't have a list, but yeah, we need to create an array. What we can use is a collection initializers. So if we just do brackets around, then we create an array of.
Nice. Woo.
Cool. Then we can pass this in instead of the syntax trees. And we are one step further.
Nice.
Haha, now it comes to metadata references. They are not that easy because we don't really know what references this text that is coming in requires. So I suppose this is also something that we need to accept as a dependency. So let's also add this to the constructor, which will be a metadata reference.
Okay.
And it's called references here. Yeah, let's call this references here as well. Cool. So let's just pass them into the C# compilation.
Into, here or where?
Yeah. But this already is an array, so we don't create an...
we don't create a new one. Easy.
Yeah. And then the compilation options.
Pass them in through that. Okay.
We could, yeah. I guess what I can imagine is that kind of an 80% use case is just, hey, this is just be a library, a DLL, with the rest being default. When users need something like, hey, I want to have unsafe code in my compilation, I want to allow unsafe code, or have, maybe that's the only thing I can think of right now that's kind of could be common or somewhat common, then we could also allow the C# compilation option. So we could make this an optional argument. If the user doesn't provide, we can we create them, kind of a best effort thing. But if the caller has specific requirements, then they can create it themselves. And I think this is called, how do they call it? They just call it options. So let's also use the name options.
Yep.
And let's pass the options here as well. And we need a closing parenthesis.
Oh, oopsie.
And now, why is this not? Oh, this doesn't fail because, because I was not kind of awaiting, expecting a nullable problem, but this also allows this to be null. So, and if it is null, we use Roslyn's default options, which are actually are console application.
It's not bad.
I think because I can imagine benchmarking, usually you just have some code. So this will be library code. I think it's kind of a console. So I'm leaning towards then creating C# compilation options that are not a console application, but a DLL, this one. So basically, if...
Why?
Yes.
Does this not work?
No, it should, but only there was a typo, I think. But
I didn't type it.
That's
sometimes with code with me, and this is my excuse.
No. I don't think AI generated code doesn't count as an excuse. You are the author.
Is that AI generated?
I'm not sure.
Compilation?
I could imagine. Well, if it's generating something that's
probably
not correct.
No, so the thing is with code with me, sometimes there's like lags, and I think because I typed D and then small d.
I did a lowercase. Okay, then it's not.
Yeah, lowercase, and then completed, and it wrote the word, but with the lowercase d. And then
I see. Then it's not. Then it's deterministically generated, and then Okay.
Yeah.
Yet still. It's tool generated. It's tool generated. Yet you are the author.
Yeah, fair enough.
Cool. And if it's null, we create one for you. But this one is not optional yet. Currently, it needs to be passed in, but we could explicitly be set to null. Do you know how to make this optional so that it doesn't need to be passed in, but it can optionally be passed in?
Is there like a keyword optional? No.
Nope.
Is there? No, I don't know.
You can say assign. You can assign it. You can say equals to, the default value we want to assume, and in our case, null. Exactly, yeah. Yes, I suppose the metadata references, they are also kind of optional. They are not necessarily required. So we could also make them,
empty or
null, which now means this needs to be null annotated.
Yep.
Because it can be null, and the user could also pass in null.
That's not it.
This is, that's not, when you put the question mark here, what is now nullable?
The reference thingy, not the, now it is.
What's the difference? What's the difference between the correct question mark being before the array and after the array? Do you know?
I guess the metadata reference can be null, but we are creating an array, and so the array can be full of nulls, but not null.
Yes. So with the question mark afterwards, the array itself can be null. With the question mark before, there may be null elements in the array correctly. So it could be, in this case, we could have a null array that is also full of nulls.
Yeah. That'd be nice.
In our case, we want a nullable array, and all is cool. Sweet. Before we bring this into shape, we got some praise.
For what?
Calmi is writing that they saw our talk from Tekorama. And thank you so much for joining us on our stream as well.
Thank you so much. That makes me so happy.
I wonder which one. Was it the one based on the ducks or the one based on you angering me?
I think I managed to anger you both times actually. So, but no, Tekorama was amazing. Like we had, it were 2 days, 2 talks, and it was really, really cool. It was a really, really fun event, and I actually loved the venue. Like it was so amazing, just even like standing in front of like this massive audience in this like cinema. It was really fun. It was really cool. And where's my robot? It's over there.
The robot.
Where's yours? Where are yours?
It's just
plural.
off screen. It's just off screen.
Yeah. There it is. Hello.
Sweet.
Awesome.
So what we need to do now is to wait a second. So where do we put in this compilation? We need to put in this compilation into the. That's for later. So we also need to store this in a field because we need to pass in the compilation that I create here down there. So let's convert this from a local to a field, and then pass it through.
Is there like a shortcut for that?
I am uncertain. Maybe there is.
Because you said it.
Refactor to field, maybe inline rename. No, there isn't.
Okay. All right. Private C# compilation, and then like this. No, why? Because it's not used.
We are now redeclaring. No, if you do a var before, we are redeclaring now.
Of course.
A new variable, a new local.
Yeah, of course. Okay, cool.
Now we can pass it through the one generators.
Oh, hey.
And I think that is fulfilling that. Cool. Now wondering if there is something else that we would like to set. So the generator driver is fine. For the syntax trees, the syntax trees also allow C# parse options. So I guess we mentioned that to allow an overload that takes syntax trees instead. What about if there is multiple texts, not just one text? Perhaps we should have we could either make this also make this, stinquers, sorry. We could also make this an array, or we have an overload, one that takes a singular text and one that takes a collection of texts, so that we get, depending on what we need, different shapes of the.
I mean,
I think we can.
Is there like a real benefit to just having a constructor with just one single one, or we don't have an array? Because
the benefit these days is little with modern C#. Because if I now say new C# generator No, wait a second. How do we call it? I guess we're still missing the reference a project, yes, please, of our busy generator. And we want to pass in now. Well, if we want to pass in multiple, so basically this is how to create a single, well, if we had an overload that takes a single string, we could also have an overload. Well, if we say, okay, there is now creating an array of strings, previously we would have written something like this. With modern C#, we can just say, we can just do collection expressions. So the difference is quite literally 2 characters. So with C#, is that C#13, C#12, C#13, that's quite neglectable. But the benefit is because if I only have a single string but I only have an array overload, the difference is with collection expressions 2 characters.
Yeah, so then that's just
is the benefit of allowing like a.
That's not a large enough benefit for me. So let's just have an array, always and forever.
Then let's do that.
Unless, I mean, obviously, if any of the viewers have any other opinions, let's hear them. But
so I suppose we should call this texts.
Texts. Yep.
And now we need to create an array of. Well, this won't work because now we need to create, for each string that we have, we need to call parse text here.
Mm-hmm.
So we do this multiple times. We could do either we create an array of the length that we need, and then for each of the texts and call parse text and insert them, or we could also use link.
Link
would be more
training here.
Link would be more concise. Therefore, each one would be more performant.
Oh.
However, in this constructor, this is not performance critical.
I mean,
the one should be as fast as possible.
Okay, but it's a benchmarking project, right? So
that's also fair.
This is like the title, and this is kind of the theme. Let's just be fast.
Then let's do the fast thing. Okay. So we need to create this syntax trees array. We now create this before with a length of, how many items do we need with the length of the strings that are passed in.
New array. Where's the length?
Yeah, you don't need the braces because we don't initialize it just yet. We don't add any items just yet. And now we need to put in the length, which will be the length of the strings array. So we have the same length.
Length?
Mm-hmm.
No.
And implicitly typed array should have initializer. I'm not entirely certain. Do we need to say syntax tree here before? Yes, okay.
Oh. Okay.
And cool. And now let's have a for each loop over this array and add in, actually, no, a for each doesn't cut it because we also need the index. So we actually need a for loop because we're filling an array. If we had a list, then we would be filling, then a for each loop would be fine. But since we are doing a bit of lower level list, then we need the.
So with an upper of text.length, or syntax tree.length. I'm confused.
Yeah, should be.
For each
branch it will be the same.
Yeah.
Syntax length will equal. However, since we are inserting into this, I think this is more intentional. But both of them would be correct. There's quite no difference between these.
No.
No,
Why?
because I is just an index, just an integer.
Oh.
How do we get the string out of the string array? We need to index into
we need
the
to
array.
index into the array.
Obacht, that's the wrong array. We need to index into, because the user is providing
Texts.
Exactly. And then we can set the result of this operation to the element, to the location in the array.
What?
Because
then we need to what?
Now we're just creating a new syntax tree, but what we're basically currently doing is, because discarding it.
We're discarding it, yeah.
Yeah. So we need to store it into that array that we are just trying to fill.
Easy. That's not easy. Why?
Because now we are trying to assign a C# or a syntax tree to an array of syntax trees. Okay. Well, yeah, there is no add method, but we can index into it. The indexer is a setter. So we say just as we say at index, just as we get the text out of index I, we can set into the syntax trees index I.
No. Keyboards like this.
Perfect, yeah. So for the string at 0 element, for the string at 0 index, we create a syntax tree and put it into the string trees at 0 index, and so on and so forth. And sparse text is also accepting parse options. If these aren't set, I wonder what the default is. If these options are null, they are passed in further and into here. And if the options are null, then the default parse options are used, which are just a new instance, which is using the default language version, which will be depending on the project that we're currently using. So yeah, currently C# 13.
Yep.
So that will be quite depending on the library. What we could say is latest as a default. No, wait a second. That doesn't really. Does this make a difference? In our case, it doesn't make a difference now. Let's leave it as is. But we should also provide an overload that takes syntax trees immediately, where the user could set their parse options if they need different ones.
Okay.
Cool.
Okay. Should we make a note of it?
Already made a note. Maybe let's build that. Let's build that overload later, because I may be leaning towards. But yeah, let's get the first use case ready. Cool. Then we run the thing, and then verify. Let's deal with verify later. So I'm wondering if this already works as we would expect. So let's see if we still have our benchmark from last time. We haven't changed anything, so I'm now wondering if we take one of these benchmarks and use one of our manual setup and one with the current setup, and they should be quite equivalent, so that we know we're still doing the same things. Is it the one with iterations where we have a little bit less setup? We have one benchmark, yeah. So I guess we also presume that we don't need the iteration setup actually. So let's kill this one. And we want those over all the tests from last time. This is the thing that we want to do. And we can remove all of that. And now we have basically the run manual and the one, let's call it library. It's the library that we built, where we now, instead of doing all of this manually, we now also create we call it benchmarker. Generator benchmarker of type T, where T is the busy generator. And we need to pass in texts. Well, here we actually create the trees. So what we can be doing is maybe just, we also have parse options with C#13, but let's just, we currently only have the string-based version, so let's use that. With formatting that I don't agree with. Cool. Let's create this field. And I suppose that's it already. So we have quite less setup. And, oh, we're missing the reference assemblies. We need these two. We cannot pass them. Don't we have an overload for that? Oh, those are the references. So we can say null here. And this doesn't work. Why? That's an IEnumerable. I see. So we wait a second. Oh, we don't have an overload that takes the metadata references. No, wait a second. Oh, this needs to be an IEnumerable. So we could have an overload where we accept either an array or an IEnumerable, or we just make it an IEnumerable. Whatever you prefer.
Well, like this?
Yes.
No. Is that right? Yeah.
No, that's not right, because now that's an enumerable of metadata references arrays. But we just want to have an enumerable of metadata references. So it's now kind of a nested collection, or a collection of collections. Now this is an enumerable array.
All right, then just
wait a minute. This is not an array. This is not an array of enumerables.
I don't know.
So
okay.
just no array.
Okay.
Just the enumerable. And now, oh, that's the options, right? So this now compiles. And so we just set up the benchmarker with this and then do a benchmarker.run. Because we're creating compilation all internally. This would be then a void method. And now the results should be equivalent. I guess we also need to do the verify, but let's do this in the next step. To also do something with benchmarker.verify. Currently that's no op, but we'll come to that. All right, so let's run benchmark. We do have a short one, yeah, so that it doesn't, it's stream friendly. And these now should yield comparable results. If they don't, then we have missed something. And in the meantime, we could tinker with, yeah, it's not ideal, doing something while benchmarking, but I guess the streaming is already obliterating this. Now I can think of how we do the verify. What we do previously with the manual setup is we run the generator one more time, but with update compilation so that we receive an output compilation. We also check, well, kind of do this already, right? So maybe we just copy this code over and bring it to shape. We need system collections.immutable. And now let's see what we want to do. So we run the generator driver one more time. We get an output compilation. We get all the... Why are we getting the diagnostics out of the output compilation if we already get the diagnostics in this collection? No need to get this. We can just say diagnostics. Cool. Do we want to abort? Yeah, I suppose when there is errors, then we can throw an exception.
But why are the errors? There's a warning.
Because we iterate multiple times, or we may iterate multiple times. So yeah, okay, from a performance perspective, this is not ideal. Well, from a performance perspective, if we say, since we mentioned we want to avoid link earlier, let's delinkify this as well. It will be more verbose, but slightly more performant. So instead of having this where loop, let's just delinkify it. So it will be, this is an immutable array, so we will be doing just a for each loop over the diagnostics. And we'll be checking if if the diagnostic is of severity error.
Oh. I didn't do that, but I'll take it.
So this should be, we need to do an if this
Yeah.
is true.
Yeah. Yeah.
Now we want to capture that diagnostics message. Maybe we also want to capture the diagnostic ID. But how do we capture them? So we need a collection where we write them into.
Okay.
And since we don't know the size of this ahead of time, I guess we could use a list of items.
It's also not very performant, but
well, that's since we don't know the size ahead of time.
Yeah.
Well, we could kind of assume we could just create a large enough array, but then we may be wasting memory. So maybe the growing algorithm there is just what we want. So let's have an array,
but like as a field.
Oh, sorry, a list. No, we don't do this as a field because we only use it in the verify method.
Okay. Where am I? Where are you? Here. Okay. But I guess on top here, right? No?
Excuse me?
No.
Where are we? Oh, no. Just after before the for each.
Okay. Errors or error messages or errors, maybe?
Errors is good because we check the diagnostic severity error, yeah.
Errors. Let's go to list of list of
let's call it list of diagnostics.
Diagnostic. No. Is that wrong?
No, actually, what do we want to create? What do we want to throw? We actually want to throw we basically want to put this into a message. So perhaps we need a string builder actually.
Oh.
So we're building up the string that we then put into the exception. So let's do a string builder instead.
String builder. Easy.
And for every exception, we could add a new line to the string saying the diagnostic ID and the diagnostic message.
No, I can't type today. I'm funny. Is there no add? How do I add this now?
There is an append.
Append. Yeah.
So, but let's first append the diagnostic ID.
Yep. Diagnostic.id. Yes.
Then in a second line, let's append a space. And then let's do an append line with the message. So we have 3 appends.
So we have 3 appends. Okay. Then new line with a space.
A space. Well, this is not a new line yet. It's just an append. So that's still the same line. There's no new line. So it's append with a space.
Line?
Yeah, no. We don't append a line. We append a line at the end. So we're not building up a line. So we do append, and at the end append line. That means we have then created a single line. So we append, I don't know, some separator between the ID and we could also say colon space maybe. And then the message as an append line, so that after that message we get a new line. Cool.
Append line.
And then at the end of the for loop, now we can check the string builder. If the string builder has, I'm not sure if it has length or count or something that is not 0, which means we added something, we can throw this exception. And do we want to have always explicit brackets, or do we also allow the short form?
Short form.
That's now a code style question.
And there's also invert if. Can I do all
but what Wider is aggressively doing is reducing the nesting, but I kind of like this. Unless you disagree, we could also reduce the nesting, but then it gets I find that more verbose. Well, this I find quite unreadable, but yeah, I like this version more. It's more. I know it's more apparent what's going on. I see.
Yeah.
This is a block, and this is happening when this is true, and yeah.
Yeah.
I personally like the visual appearance of this, or the parsability. And then we throw an exception. I guess, do we also need a separate exception? Well, maybe we do we have an improvement. We'll come to that. So we already do that. Cool. We do get a suggestion. Eric likes the fluent append. I totally forgot that append and append line return this. So we can chain these. We don't need to say.
That's cool.
We can do something very link-like.
Like, no.
Well, we still
With
need dots. Yeah.
But-
and then need to kill the semicolons
of course.
because they're no longer terminating.
I did
And
something. What did I do? What did I do? Oh no. Can you hear? Yeah, okay.
the parenthesis was missing.
No, sorry. I just had a funny pop-up on my end. I fixed it. Everything's fine.
Sweet. And
worked.
yeah, if there is something we throw, that means, and then, yeah, we could do more stuff later. But this is now, so this is now verifying if there aren't any errors. Oh yeah, what we also wanted to check is if.
Yeah.
We could also supply texts that we then verify that they are indeed true. But maybe let's come to that later.
Mm-hmm.
Let's see how far we get with what we have. So the benchmarks we're running. And are those adding up? Yes, I suppose they are quite similar.
Nice.
That's surprising that they actually are so similar. But I mean, statistically, but that's good. So it seems that we did everything right. We didn't miss anything. But now we also want to do the verify. And actually, what is this generator doing? The busy generator. I totally forgot. Is it actually generating something? Oh yeah, it's sleeping and generates the text with the amount of nodes that we have. So what we could do is also in the verify allow optionally a array of string that we then check the generated sources against. So let's also let's optionally pass in an array of strings.
Like, should we have an enumerable string or no? Array.
I suppose we could make this an array.
Array of.
There is
string?
this doesn't.
No.
An array is with the brackets.
Of course, with the string array. Nice.
And we could call this generated texts, maybe, because those are the ones that we expect to be generated. And now, now we need to ask the.
But it should be optional, right?
Yes, so we can also make them nullable, yeah.
And then.
Cool. So we can't use this output compilation because I don't think we can discern whether, or can we? Is there a way to check the compilation whether the sources were generated? So they should have some syntax trees. And do these syntax trees have information? Oh, that's an enumerable. Do they have information about whether this was generated or not? I don't think so. So what we may want to do is to actually capture the resulting driver, because the driver has a result, and this result has the generated trees. So we now want to iterate through these generated trees and compare these with this generated texts. And if there is a diff, we go boom. would you like to write that code?
For each.
Yeah, it's a good start.
Wait,
Perhaps
did I?
we may, since we need indexes, since we kind of have generated trees, we may need a for loop. Comment this out because it's causing syntax errors, which does confuses the tooling.
How do I? Okay. Yes. Yeah, I think it was confusing at all. And we want to go to, can I not go driver trees dot length? Easy. And then we want to take.
We want to get the string out of, so that's a syntax tree that we can stringify. We want to get the.
Oh, stringify.
Yes. So yeah, no, that was good. We need to index into it because that's basically the equivalent of our for each loop.
Oops.
And then we should be able to. Not sure if toString works. So toString, is that an object? I think we had this last time. There is, I think, a text property, or I think syntax trees then has a text property or something.
Get text.
What? Get text, and on that this returns a source text, and on that we can call toString.
Oh, perfect.
Can we? Yes. Yes, we can.
Okay.
So we are not using this. So we should store this in a local variable, like generated text something. And now we want to compare this against.
This is easy naming.
And now we want to compare this against the whatever we have in this index. So on the same what's the word, location.
Which index? Sorry.
So we have on index. So now we're going to go into the generated text that the user is passing, index into that, and compare it with the generated text that we just extracted from the generated source trees. So we compare what was generated with what was expected. And if it doesn't match, we throw an exception.
Okay. But what is... Oh, this one. Okay. And then if... No. Okay, wait. Generated texts. No, sorry, I'm kind of stuck. So
yeah,
we have an array of generated text, but how do I know?
Yeah, so we need to index into the same, also into I. So we're now comparing one with the other.
Okay. So it's not like a contains or something.
Well, we could, yeah, but that's difficult.
Yeah.
Because because I would also like to show the diff. If they don't match up, I would very much like to show the diff to help exploring what the difference is and not just say something is different. But yeah, so we kind of need to do this like that. Problem is, generated text is optional. If no generated texts are passed in, we shouldn't be verifying, because now we're indexing something that's null. This will crash with null reference exceptions. So we shouldn't do any of this if nothing is passed in to verify.
Okay.
Basically, this is now an opt-in. This verification is an opt-in.
Is null? Perfect.
Is
not null.
It depends. Well, if you return, then yeah. If we continue, then no.
Is not null. Or should I write is not?
I like is not. Yeah.
Yeah.
But that's preference that there's no performance difference on.
No, it's nice.
On
okay.
On arrays.
Oh, that was nice. The formatting.
And yes, if it doesn't match up, then let's throw.
Throw. Why does this now start here? Anyway.
And maybe with the text, yeah. Now the question is, what do we just say? Diff, just say something. We're gonna improve it later.
Okay.
Yeah. that's actually all right. But we're going to improve that later. Cool. So this should now, well, I see one potential performance, well, issue is, I guess, an overstatement, because this doesn't seem to be cached. So we are getting the results twice.
Yeah.
So we should access this
Get
generated
it
trees.
once.
Get it once, exactly.
Trees. Oops. Oh my goodness. And
I think this can be refactored into, if you mark, I think it can. If you mark a portion and then do Alt-Enter, I think this is this.
Oh, really?
Introduce a variable. This is what you could do, yeah. But this, will not work because we're extracting the length. So this is now an integer.
Yes.
Needs to be the trees.
So trees. And then here's trees dot length. Perfect.
What is your preference on using var versus using explicit type?
I know. I'm so sorry.
No, just wondering.
Because
no.
we
Just
always did
you like more?
explicitly.
Yeah.
And but at work we have this thing that we only use var. So now I'm kind of because I go to work every day and only streaming like every 2 weeks, and that's why I don't do it. Like it's just like an accident. It's just
how would you like to do it in this project?
I'm happy either way. I know you like
now...
explicit, and if you still like explicitly, then we can definitely do that.
I personally do, yes, but
I know. I'm sorry. I really didn't do it on purpose.
We can also go var. It's fine because my work now we also use var, and I'm kind of getting used to it.
But we're not at work. This is like we're not at work. We need to get work out of our head. We need to be different.
So I'm just gonna do a bunch of alt-enters all over the place.
Yes, please. Sorry.
De-verify. Okay, cool. Now let's see if that is working as expected. So we don't need the one. Let's benchmark. Let's kill this one manual one and only ours. And then for the cleanup, we don't need to do any more of that. And we just say verify. Oops. We just say verify. Now, what if we have an... Where's the input? Here's the input. Cool. Now, what if we have a syntax error in here? Oh, yes, a syntax error in here. And if you want the benchmark, this should fail. Eric says var rules. Now it's kind of, if you also prefer var, then it's 2 against 1. So I must yield. If you would like to verify again, I can't. I'm out of power. Shall we go var?
I think you could do it from now on. I'm not gonna or do you want to change all of it?
It's just three.
But it is the writer suggestion as well. Oh yeah, let's do it then. var it is.
Yeah, I think writer per default does the most concise thing. I guess now, since let's stay consistent. In this case, what do you prefer in this case? Do you prefer this or prefer this? Which one do you prefer here? Have to type on the left-hand side or on the right-hand side?
Yeah, left-hand side. Let's not be too crazy. Yeah.
And cool. And okay, so we don't have any errors. That is surprising.
Oh no.
That is surprising if we initialize our here, because that's an apparent syntax error. Did I not save? And then we run, and then we verify. This should have some diagnostics. The question is, what are these diagnostics now, actually? these are these the diagnostics from the generator run? Diagnostics bag, I suppose. Oh, okay. So I think those are the diagnostics from the generator. The generator didn't fail. I think those diagnostics is when the generator is failing. Do we also want to have diagnostics of the compilation? So if the compilation is bad. Because if we want to do that, then we would kind of do a copy paste of that. And instead of going through the diagnostics, we go through the output compilations diagnostics and then have the same thing. Well, I guess we could refactor this into a method, which we'll do in just a second. But now this should throw if, I mean, I guess that the generator itself is fine, but we had a problem in the compilation, and now we would surface this as well. Is this what we want to do?
Yeah.
Because this should now be throwing and saying invalid syntax identifier not found, something like that. Maybe for the next one, we also do the verify in the, actually, let's write a test because this is way quicker than, yeah, so this will kind of fail. Exception cleanup, CS member modified public must precede the type name. Yeah, okay. Some parse error. So cool. Let's run a test because this will make things way quicker to test. Never did T-unit, but I suppose since we have the generator benchmarker, we will have generator benchmarker specs. I will be, okay, just thinking about how to write a test. It's just a test. Okay, that's cool. With T-unit, and we, not sure what the name yet, basically do the same setup as we have for the benchmark. Well, we don't need the run actually, we just need this. And, oh yeah, we are missing types. Let us, what do we need? We also need Roslyn. Well, actually, when we refer to our production project, then we should get it for free or implicitly, transitively. That means we should just be able to hit Alt-Enter on our busy generator, but it doesn't find it. So let's include the reference to that project manually. Why that doesn't like tabs, okay. And now we should be good to go. Oh, because the busy generator is in a different project that's only defined here. Let's copy this one over there. And now we should be good. Oh, we also need the reference assemblies. So this is also a dependency that we need, basic references. Wait, have I added this already? No. And go into here. Now things should come together. Wonderful. Oh, Writer doesn't seem to have an integration for T-unit yet.
No.
So we can't really, we can't run this test out of Writer. Okay, so we need to go into the command line.
Yeah.
That's not the greatest. Oh, well, we can say one tests here. Oh. Okay. So it just doesn't find the
shortcut.
The tests. It doesn't discover the tests, but yeah, we can still run it. So it seems, well, it's okay. And
sorry.
one. Also because we do a lot of sleeps, right? And this now, yeah, we get the exception. Yeah, it now fails when we have an invalid input. So I guess we should properly form the test to see. I'm not sure, how do you do exceptions with tunit?
I don't know.
Do we have an example? No. Let's see if the APIs are kind of intuitive. If we say assert dot fail, assert that, assert throws, assert throws an invalid operation exception. I guess the to do is we should throw a custom exception. And this one is taking most likely a delegate. Yes, so we gonna the verify. That's the one thing that we expect to fail. So basically, oops, have the verify here, and now this test should pass because it does.
Woohoo.
Oh, now I discovered it. Oh, I had to build it once. Okay. Now the test should pass. Excellent.
Amazing.
But what about the diff? So if we have a similar test, then in the verify, we could also pass, I'll just run it so we see something that we can run. What if we pass, because what is that we expect out of the generator to generate? What was the thing last time? I think we said 16 nodes, yeah. So what we expect this generator to generate is basically this string. Not this string, but this string, 16. Let's see. Oh, we have an array. So we need to put this into a collection expression. And yes. Oh, it doesn't find it again. That's a bit inconvenient. So we need to build it first so that Rider is discovering these tests. Now we can run it. And, oh, yeah, maybe we should fix the syntax error. And let's make this as short as possible and say syntax error. There we go. And this one does not throw away. Oh, because it's correct. Oh, have we? I want to see it fail.
Oh.
I want to see it fail. Fail, fail, fail. We should remove this to sleeps. Generated text doesn't match. Now I would like to make this experience better by actually providing a diff. I think this would be then also be the last section of today. And this could be then something that we may be shipping in that state, other than providing custom exception and also providing a little bit more overloads for convenience. But I guess this then would close the tool for the first release, where we now would like to make this to actually show the diff. How do we do that? There is something called diff diffplex, I think. Is that called diffplex? I think that's the library where we can diffplex. Let us, do we get the, go to NuGet. We need the package reference of the latest version 3 months ago. Because this package, we can basically pass in strings and it gets a line by line. similar to Git. When we see in Git, maybe I can show GitHub Desktop. When you do a Git diff, you get benchmarking. Oh, that's the wrong benchmarking project. That's the right benchmarking project. We don't have a diff, but we get like, okay, plus if something, it says plus if something was added, minus if something was not added, and nothing if nothing was added. And we could do the same thing to basically show the diff between what was expected and what was actually created.
That'd be cool.
And diffplex will be helping there significantly. And we need this then also as a transitive dependency to our project. So in version, we also need to go to CPM, that's Central Package Management, where we will add this package version as well. Yes. Order it alphabetically. And let's go to the documentation. Copy this, because this is exactly what we need, plus and minus. And instead of, let's maybe just paste it here. Oops. I'm used to another keyboard now. There we go. And oh, why don't I just paste it in here and change what we need? So we go through the generated trees.
Yeah.
For each tree, we now want to do a bit of a diff. Okay, so, well, we could just check if they're not equal, then we could do the diffing. Meaning that, well, we will definitely refactor this into a couple of methods. Now it's a bit verbose and unwieldy, but we'll get to that. We create an inline diff builder. There's a before and after. The question is, what should be the reference? Should the diff be, what should the base be? The expected version or the actual version? So what do we diff to?
Well, expected, but was actually, right? Or I don't know. From that's what I always know from like tests. So this is why I kind of see that more often. So maybe it might be that other people also see that more often.
Can you repeat that again, because I'm not sure if I got it right.
So that you put the expected first, and then we diff the actual to
the actual.
Yeah, but
so
whichever way you think is better as well.
No, I'm not sure. Let's see.
Let's see. We can change it.
So afterwards. We get the diff, and do we know if there? Okay, yeah, we know there is a difference, but we don't know where it is. So we now, with this diff builder, we can go through all the lines, and if something was inserted, I guess we could say we could do a plus. So maybe again we now do a diff, a string builder. Diff text, new string builder. String builder also takes a capacity. So we can, again, because string builder internally, I think, well, it doesn't do array growing, but I think it's a chain. It has some capacity. It also has some default capacity. And if this default capacity is exceeded, it will create a new string builder and has this new string builder referenced by the old string builder. Or is it vice versa? Not certain. But you basically then build up like a linked list of string builders. So we don't throw away the arrays, but we create new instances. This is how it grows. But we could also optimize it if we know roughly the size, because we kind of do, because the roughly size that we will generate is the expected text dot length. Or is it the generated text dot length? It's whichever is larger.
Yeah.
How can we like the larger version? I think that's math.max, where we pass in the length of the expected text and the length of the generated text, and we get whatever is larger.
Ah, that's cool.
And I guess then that's well, there will be more. We will definitely add another string builder, but we have a good assumption. Well, we could also say something like, I don't know, and add 100. But maybe that's good enough for now. We could do some benchmarking and see common scenarios and maybe make this a little bit better. But that's, I suppose, good enough for a start. And then this is a line. So we always then append a line where we say plus. Well, actually, we append a plus if it was inserted. We append a minus if it was removed. Oops, I copied the wrong thing. Oh, I'm also terrible at copy pasting, so it seems.
Finally, you learn something from me, right?
And we do 2 spaces if not. And then we add, and then we append a line with the text of this line. And then at the end of this loop, that's a div text. Yes, so at the end of the loop, it definitely should be refactored into methods because that's it looks weird. Again, invalid operation exception, but we'll throw a custom exception later with that, or we could also say div found div text. Actually, there should be another. Well, we could also add this to the string builder to say we lead the string builder with append line div found where base is expected. And that means, how many characters is that? 1, 2. Oh, actually, I can just hover them. So those are 34 characters. So we just add to our estimation 34 more characters. So we have a good estimation to start with.
Cool.
And then we print it. And this should now give Jason is going to a meeting and missing the VAR discussion.
No. Yeah.
Precious discussions about VAR.
Yeah, VAR won in the end. But yeah.
And here we get a diff. So the base was 17. This is what we expected. That's what we expected, but what we got was 16. We could make this a little bit more exciting if our generator is maybe generating a little bit more and saying hello and also world. And this is also what we then should be expecting. We would be expecting. I really don't like this default formatting of Rider here.
Oh, yeah.
And it doesn't like spaces. Oh, it doesn't like tabs. We have hello and...
No.
Oh, now it gets confused with both our edits and I'm reverting your code.
That's funny. Okay, I'm gonna stop now. Hands up.
There we go. And now this should be showing something a little bit more interesting. So we should get the first and the last line without the prefix, and then the middle line has a plus and a minus. And there we go.
Yay! Awesome.
And if we would be mega fancy, maybe we could do something fancy. Just wanna.
Yeah, let's be fancy.
Wanna just outline it. What we could do. What we could do is then also to append. To make this markdown. So we emit div at the beginning. Wow. So we make a code fence, say this div, because this is what markdown or the diff, this is what the diff code block is doing. And then at the end, again, say those closing braces, closing code block. And if we run this, now we get this included when it finishes, which means what we can do is now just paste this into a editor that supports Markdown, opening Visual Studio Code on the side. And if we just paste this in, oh, I made a mistake. Yes, this is of course at the end. There we go. And we also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more characters. And running this. Yes, we should remove the thread sleeps. This will make it immediately faster. Now pasting this into, and now we get this highlighted a little bit in color, and see that, okay, so the hello and the world are as we expected, but this notes line is we expected 17, it wasn't, instead it was 16.
Okay. That's
so we now
fancy.
see if something gets differently generated than what we expected.
But my question is, because in the console itself, it looked a little bit busier, right? Or is it okay?
So yeah, I guess maybe this is some option that we can set in the diff view. We could say for the verify, per default, we could have a well, this is create markdown kind of a thing. Per default false, markdown. And if we do want markdown, then we can do this. Otherwise, we don't. Yeah, kind of a thing. And yeah, so I guess then the next moves are providing some more overloads, custom exceptions. And one thing that we would need to be testing a little bit more is, actually, that's maybe also interesting to finish the stream on. What if I pass in 7 texts because I expect 7 documents to be generated, but actually only 2 documents are generated?
Mm-hmm.
What should happen? Do we, for an exception saying, hey, expected 7 texts, but found 2 texts, without then showing the diffs? Or do we basically try to compare, get the diffs out of them, and eventually when we expect more, but there isn't more, or vice versa, if there is more that we expect, then append a message as well? Which leads me to another question. If we have 2 documents generated, and 2 of them, and both of them differ in what was expected, do we want to print only the diff of the first one, or do we want to print the diff of both?
I guess both.
This is now a bit of a design decision.
Yeah.
And I guess then another scenario would be, what if we expect 3 documents?
Mm-hmm.
Actually, 3 are generated.
Mm-hmm.
The second one differs.
Yeah.
Do we want to print from the first and the last one the non-diff, or do we only print the ones that differ?
Yeah.
Only differ?
I think only differ, but
only the difference?
Yeah, otherwise we sort of like print a lot, right?
Yeah. If they don't match, if expected.length is not generated.length, if we expect more or less than were actually generated, do we then go into the diffing? Yes or no? Or do we just say, hey, we expected 3 documents, I found 4, nothing at all is happening?
Yeah, that sounds good, because, yeah, to print, yeah.
Amount not matching is a, show 2 versus 3 documents or something. And I guess this then eliminates the other question, because if we were still going into the diffing, then the question would be,
What do we show?
then only show partial diffs, or how would the behavior be there? But if we immediately say, hey, expected 3 but found 2, then what we perhaps could do is, in that case, to give some indicator to say, because generated documents also have a generated file name, we could print, if they don't match, we could print the generated file names for the case that, so for this case, now they don't match. Let's print the actual generated document names. So as a bit of a helper that I know, hey, those documents were actually generated. So I get some indicator of what might be wrong. Because just saying this number doesn't match doesn't really give me too much information of which document was generated too much or too little than what I expected it to be. So we could, well, this is still called class 1. I suppose we should rename this.
Yeah. Oops.
Oh no. General benchmark driver. Well, it doesn't really matter as a library, but it actually doesn't matter, yeah. Well, from a compilation perspective. So if the generated trees, so we can say generated text is not null, if the generated text.length does not match the actual generated trees, so maybe let's call this generated trees, does not match, my pointer tool just broke down.
What?
I can't. Wow. No. Could we start it? No, never mind. If they don't match, we could say, well, let's start another string builder. To start with, there was a completion that I would like to apply. Generated trees and expected trees have different length. Okay. And then we shall append lines per actual tree. So for the generated trees, for each generated tree, we can append, maybe saying, kind of the markdown dash minus the name of the, wait a second, that's a generated tree. This doesn't have a document name, does it? Oh, it does have a file path. It does have a file path. Okay. The question is this then the same as the hint name? Because I'm hoping to get the hint name. Let's see what will happen. I'm not sure what's going to happen. And let's get rid of this. No more thread sleep. This should make this significantly faster.
Pew. No. Oh.
Because we would expect this to say count.g.cs. Why do we get the diff?
Did you save?
Oh, sorry. I was editing the wrong test, I suppose. No, I was correcting because we now expect 2 trees. Interesting. Oh, I don't throw an exception. Invalid operation exception with the message to stringified. There we go. Oops. Now this should do the trick. And what we now get is oh yeah, my tool broke, so my shortcuts don't work anymore. Generated trees and expected trees have different length.
Yep.
and we get the file name. So we know, okay, count.g.cs was generated. I'm wondering if we could cut this off, because that's kind of lengthy. Can we cut this off? Because what is that? That is the name of the generator. Because file path, that's just a string, right? Yeah. So we don't really know this must be something from the driver then. Do we know the generator? Well, we do get the one result, right? So perhaps we should store the one result. And maybe the result has, oh, we said var, right? Has this information. No.
Oops.
Maybe that's actually then the generator itself. But because that is the, wait a second, that's here. Is that the assembly name? And that's the type name.
Yeah.
Well, I suppose we could cut off everything until the final slash.
Yep.
I can't exit anymore. Oh, there we go. Okay, we need to stop. I close this tool now because it's causing problems. So we could just basically cut off everything after the final backslash. Do you know how to find the final backslash?
No. But I know that I once did like a little C# course, like a beginner's course, and we definitely went over it. But yeah.
So we need the
all
index.
The trimmings.
There is operations like the index of.
Yep.
But we need the last index of.
Okay.
So we get the last index of the backslash character. We need to escape it. So this will then be the last index of. We kind of assume now that this always exists. This may be, in some cases, this can be -1. -1 meaning not found. So if it is -1, that means it's not found. So we just can print the file path. So perhaps we do it like that. We have this. Then we, in this case, we append the file path. Otherwise, we append here, but a substring with from the last index to the length. And I suppose there is a range operator for that, isn't there? Some slicing. This should be, oh, well, do they have slicing? No, string does not support slicing. Now I'm wondering, does String Builder have overloads for spans? Yes, they do. No, do they? Append value child. Read only span. Excellent. So let's do a read only span instead, because what we're doing here when we do substring, we create a new string. We're allocating a string that we then feed in. That's not ideal. But what we can pass is just a read only span. So we can say as span. And spans support slicing. So then we slice into that. And this doesn't work because it's not assignable to parameter of type string. Wasn't there a read-only char accepting? Oh, append, not append line.
Two-stringed it. Oh.
Yeah, but we don't want to do the two-string. Otherwise, we could just use substring. Append supports read-only spans, not append line. And then we do an append line at the end and are good to go.
Perfect.
And this should now, so in the case we have a backslash, if we find a backslash, we kill everything before that last backslash. But if we don't, we just take the full thing because there is none.
Okay.
And this should now have this a little bit shorter. Argument not found. What's the problem? Do they not have an overload? But I found read only. Didn't I see? Was it just span of t? Did I not see read only span? Am I getting? I thought it can. Let's check the string builder docs. Append read only span of char. There it is. And this is a. I think I'm getting insane now.
Maybe
read only
some
span
braces.
Maybe.
No. What?
Yeah, this is really troubling me. But we saw them. Oh, wait a second. No, read only span overload does exist since. Oh, on .NET Framework it doesn't exist. On .NET Standard it doesn't exist. On .NET 9 it exists.
Ah, okay.
And so let's for .NET 9. Yes, we got. We can make this way shorter with the slicing syntax. Actually, we should know because we talked about this. We can use the range syntax. No, wait a second. Can we use the range syntax? No, we need to use the slice syntax. We can't use because range dot last index. Oh, now I'm wondering.
Let's
try. Say as span and slice into last index of semicolons is expected there. So, and this isn't this saying everything up until last index? And not everything from last index? Do we need to say? No, I'm now confusing things. Slicing.
I mean, can we not just see what comes out?
Yeah, let's find out. What's the point? Yeah, that's the slicing syntax or the implicit slicing syntax. And yeah, okay, of course, this doesn't now run on other target frameworks. So we need to do multi-targeting. So since when is this available? This method is available since Net Standard 2.1 and Net Core 2.1. So we go to the documentation of .NET preprocessor directives and can then use are they not here? Did we move them? Did I scroll over them? There they are. We can use these and say, hey, if it is Net Standard 2.0 or greater, or not Pragma, so we can say conditional compilation if it's Net Standard or greater, or if it's .NET Core, what did you say? 2.1 or greater, then we can use the slicing version. Otherwise, we need to use the string-based version. and then end this block. So for the other versions, if we now switch to Net Standard 2.0, where this doesn't exist, I guess we should actually be able to use a very similar syntax, but this is then just string. Oh no, they don't. Okay, we can't use. Yes, we don't do a span, but we now just have a string. So this is now a substring actually. Substring. And if we run the tests in Net in a version that does support them, let's see what is going to happen if we. I can't debug this. I need to go here. Debug this unit test. Damn it! Why is it still not? I now conditioned it, haven't we?
Yep.
Net framework. It's using the string-based version. Standard 9.0.
Looks good.
What is the problem still? Predefined system.range is not defined or imported. So with Net Standard 2.1, well, I guess we could use, if we have there is a polyfilling package. Should we include that? Well, I guess we're over time already. Let's also include that. Polysharp. This is now to enable this syntactic sugar, where we can, I think it's called Polysharp on NuGet, now add to our tests the NuGet package Polysharp. Haha, Polysharp, huh? Somebody wants to do some spoofing. And
you could do Polysharp pest.
Yeah. Use the right option. Include generated types. And because we want this to be generated, so because this property is accessible, Polysharp is basically a set of source generators. And we make now this accessible, because what we need is the range. So I think that's system.range and system.index that we need to have source generated, so that this slicing in there, because this is what we had in the talk about. If we use implicit slicing, then we need the index and range types. But this does still not work. Is the generator kicking in? Source generators. That's the T-unit source generators. What about the Polysharp generators? Why are they not kicking in? Did I make a mistake here? That's the correct name. Index and range. Oops, sorry, shortcut's gone. Was it just? Is it not the full name? I thought it was the full name. Polysharp, there it is. Why is the Polysharp source generator not source generating? Well, need to figure that out. Until then, maybe if I reboot and then everything is cool, maybe Sharper needs Wider needs a reboot. But then when this types then are available, then this syntax would work. Until then, so we will now, for now, just do the good old, the substring version of it. So instead of having this, we need to fix this later. Then just say substring. So tree.filepath. Dot substring, where we start from last index off and go until the end. So this previous. Oh no, not the length. Substring, is that int and int? Is that length, right? Okay, so we need to have length minus last index off. Otherwise, we would shoot over. And can apply indexing to an expression of type. Oh, yeah, this needs to be parentheses. Okay, cool. And now we should get, let's check what we get. It doesn't allow to evaluate this expression. Okay,
No.
so let's check the message.
Yeah.
And it says, no, something is off here because it's still the full string. Because I think that's the equivalent of I can't wrap my head around. What is the syntax? We should know.
What are you trying to do?
I think this is we need to slice from this last index off until the end. And I think it needs to be like so. So we have, because the slicing is, if we would do the full version, it's .slice, and we need to pass in the index of length and the length of what we want to slice, which is now the full length without the slice index off. And I think that's the equivalent of it. So this should now be, this may now be doing what we expect. Oh yeah, it was in training is also saying it's last index dot. And not allowed to evaluate. Can I shift F9 it and say please? No.
Yeah.
And say 9 dot to string. And yes, now we got it. We moved.
Yes.
Cool. Well, the slash is still there. The slash is still there. So I suppose we want to do a +1. And do we need to then put it into parentheses? And also do a, for the non.NET 9 versions, since you do multi-targeting, also do a, basically have the same syntax here. And for this also do a +1 and a +1. And now when we run the test, we should now say that we have a different amount of documents. Well, it would be cool if it also says what the difference is. So the final improvement is to say generated this amount of trees and expected this amount of trees. And now we should have a quite actionable exception that is indicating what is wrong. And if we put this into there, so we generated 1 tree. Well, we could improve the grammar here a little, but expected 2 trees. Maybe let's have also one final message of generated trees colon. And this now also says, now this should be quite a complete solution. Saying we generated 1 tree, expected 2 trees, and the generated ones are count.g.cs. And now I know, oh yeah, I expected another one, but only count.g.cs was. So this could now give some indicator of, because if I have like 7 documents and I see, oh, where is special document 9.g.cs? Something is off.
Yeah.
And I believe we now have a generator benchmark type that allows benchmarking that would also allow a bit of memory, a bit of profiling. If we were going to the setup one last time, just copying this over to here. Oh. The difference between Windows and Mac is terrible. If you switch, I always press the wrong keys. And we create the benchmarker, and we don't really need to verify here because I don't like the formatting that you suggest. Also, let's top spaces. There we go.
Yeah.
And then we could say, hey, cool, please run for, what did we have earlier? Well, this may be a little bit too much, but for 1,000 times this generator. And let's do some profiling. Maybe let's, not the tracing one, I think sampling, that's a bit quicker. I think tracing is more precise. And let's see if we get, why is 1,000 way too much?
I don't know. We'll see.
If this now runs for, I don't know, ever.
Well, it won't run forever, so that's
it won't, yeah.
good. Oh yeah, okay, it's quite a while. But there's no
100.
Okay.
Excuse me, there is no?
Nothing. Sorry.
What? Do I have some code somewhere that does additional stuff that I totally forgot about? No.
Some sleep somewhere hidden.
This should be gone. Oh, how is it back? Oh,
how is it back?
Yeah, because I removed it. We made a copy of the generator. We made a copy of this generator. That's, yeah, okay, cool. Now we can go back to 1,000. Yeah, this would have, we'd have waited a long time. Yeah.
Yeah. Would have done a lot of like a little dance.
Oh yeah, that's more. Okay, I just did once in a second. Okay, now it's too little. But yeah, we would see, I guess this is, we need more to separate a bit of noise out. Yeah, and now what would we see? That some in the, yeah, initialize of the busy generator I'm just wondering if there's something that we could deduct. This is where we add source code. Yeah. Well, I guess our generator doesn't really do too much fancy code. But if it was, we should be able to get some more insights into that. And yeah, and I guess that's quite, with all the code that was previously needed to have the driver and create all of that, to just have a simple benchmark that is using a bit of code, some basic assemblies, and then run it for a bunch of times. Yeah, it fits on a screen. So I'm quite happy with that type, and we'll be publishing this as a NuGet package, and I'll be using this quite a bit.
Yeah, you won't be able to lose it. That's fine. I mean, I don't think we can really call it overtime. I don't think like. I think maybe the stream is just 3 hours. I think we have to sort of like.
We have to admit it to ourselves that
we do a little bit.
But if we schedule it to 3 hours, will it then run 4 hours?
Oh,
I don't think
right.
That's not sustainable, is it?
But that's actually so true, because if you remember, like 3 years ago, we said we'd do the stream, and we said we'd stream for 1 hour, and we did that like once. I think.
Oh, I see. Okay.
And then it was 2 hours, and then we schedule it. So you're probably right. If we schedule it for 3 hours, yeah. So let's stick with you for now. Who knows? Thank you so much, Eric. Oh my goodness! No, it was really, really awesome to see so many familiar faces here. It really makes my day when we all come together and and you spend the evening with us coding. Thank you also for Stefan for obviously taking the wheel on this a little bit, because otherwise we would be here until, well, for a couple of hours longer. And yeah, don't forget to subscribe to like we usually say like and subscribe. You don't have to like. We it makes a, you know, it's very precious to us if you do, but you don't have to. But what you do have to is to subscribe, so you stay up to date with our upcoming streams and you don't miss any of the content. And if you have any questions, suggestions, or just want to reach out, obviously that's also where you'll find us. And yeah, well, thank you again, and also thanks to, you know, people watching from overseas. It's so cool. And like, yeah, people from all over come together and code with us. So thank you so much.
So we will be announcing when we have published a share package over social media, and we don't have an exact date just yet, but in roughly 2 weeks, plus minus a day or something, we'll be back.